Hi everyone, it's the Math Lady, and today we are talking about difference of squares. Difference of squares. I've seen this called a few different things based on the book. Difference of squares is the most common name I've seen, so that's what we're going to use. This has to do with factoring. Now, most of the time when we're asked to factor something, it will look more like this. Let's say x squared plus 5x plus 6, and we're asked to factor that. There's usually three terms. There's one with a squared is the most common. Of course, there are exceptions, x to the fourth, what have you. We're going to deal with the most common one that algebra students are asked to factor. We have an x squared, an x, and then just a number, a solitary number for the last term. So that's our most common one. But every once in a while, whoa, that's not what I meant to do. Sorry about that. Every once in a while, we come across something like this. And we're asked to factor that. Well, as you may recall from previous videos talking about FOIL and multiplication, when we're multiplying things that have been factored, I'm going to slide this up just to hide that for a second as we look at this. If I had, it's like a minus 5 and a plus 2, and I go through my process, my FOIL process of distributing that, just going to do that real quickly, I end up with those three main terms. I have an a squared, I have an a, and I have just my plain number. That's the pattern. So how on earth can I factor something like this where there's only two terms? Well, it's because there's one very special thing, which is called, I bet you'll never guess what it's called. It's called the difference of squares. And what it is this is our pattern. Let's slide this over. If I have, let's say, just going to pick a little random one, x minus 3 times x plus 3. If I were to multiply this out, what would I get? Let's try it. X times x, x squared, x times 3, or positive 3, gives me plus or positive 3x. Negative 3 times x gives me negative 3x, and negative 3 times 3 gives me negative 9. Now, as you'll see here, I have a positive 3x and a negative 3x. They cancel each other out, and I am left with x squared minus 9. So if you look at our original things that we were multiplying together, we had x and 3, x and 3. And this down here is that first term x squared, and this second term is the last one up there, 3 squared. So that's what happens. That middle term with the x by itself gets wiped out, canceled out by the positive and the negative opposites, and I am left with my first term squared minus my second term squared, x squared minus 9. So if I look at this one over here, x squared minus 16, this is something to look for the instant you are asked to factor something with only two terms. The very first thing always that you should check is this a difference of squares? The majority of the time it will be. There's one to look out for, which we'll get to at the end, but that's the first thing you should check for. And the way you check is you look at the first one and say, is this a square? Then we look at the last one and say, is this a square? For numbers, if it's a number that you're unfamiliar with, that's not in the times tables, and you don't know if it's a perfect square, you just use the square root function. Usually looks like that. It's a button on your calculator to see if it is a perfect square. For anything with an exponent, any even exponent, it is a perfect square. Because, let's say here's x squared is x times x. Okay, so that's a perfect square. What if it was x to the fourth? This is just a little side note here. Well, I've got two matching pairs. So x to the fourth is x squared times x squared. It's a perfect square. So you can see x cubed would not be a perfect square because I can't divide it into two matching terms to multiply together. So that's why, just very quickly, if the exponent is even, it is a perfect square, and you just divide that exponent by 2 to find its square root. So that's a little side note there for you. Exponent trivia, woohoo! So most common one we come across is x squared. So the square root of x squared is x. The square root of 16 is 4. So the way I would factor this, x and 4 are my two terms inside both parentheses. One is plus, one is minus. And really that's all there is to it. So I'll do a couple here just to show you this pattern. It's one of my favorites just because it is so straightforward. So I look at this and I go, ha, two terms. I need to check if it's a difference of squares. Is my first term a square? Yes, it is. That's an even exponent. Square root of x squared is x. Square root of 81 is 9. So I'm going to, I wrote those way too far apart, of two parentheses. With x and 9, one is plus, one is minus. And that's my answer. The same thing is true, let's say, if it was like this. 4x squared minus 144. Why not? Is this a square? When we're trying to find a perfect square and we have numbers and variables together, check them individually. They both have to be perfect squares. So first, is 4 a perfect square? Yes, it is. Its square root is 2. Is x squared a perfect square? Yes, it is. It's x times x, so its square root is x. Now 144. Is it a perfect square? Yes, it is. It's 12 times 12. So now I have my two terms, 2x and 12. One's plus, one's minus. Done. Easy peasy. Or say easy as pie. Got a lot of southern metaphors for that one. That's where I'm from. Don't know if you can tell, it comes out on occasion. Okay, so let's do one just real quick with a higher exponent. Let's say if it was 16x to the fourth minus, let's say 36x squared. Same rules apply, even though it's, it looks more fancy than our previous one. We look at our number first. Is 16 a perfect square? Yes, it is. Square root is 4. Is x to the fourth a perfect square? Well, is the exponent even? Yes, it is. So it is. We divide the exponent by 2 to give us our square root, x squared. Again, the reason why is because x to the fourth is x times x times x times x. So it is x squared times x squared. And that's the definition of a square. You can take the same thing, take a number or a variable, what have you, multiply it by itself, then that is a perfect square. All right, other side, 36. The number first, is 36 a perfect square? Yes, it's 6. Is x squared a perfect square? Yes, it is. That's an even exponent. I divide it by 2, get x. So those are my two terms. I write them twice. Plus, minus. And that's it, boys and girls and cats of all ages. That is how we do it. The one big caveat that I put out here, and more, not really a caveat, a warning, is that math tests and teachers' handbooks love, 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 love to throw in something like this. And to trip their students up. And what is the big thing wrong here? You're taking your math test and you go, oh, 16x squared 25, there's 2 terms. I got this. 16, that's a perfect square. That's 4. Square root's 4. X squared, that's a perfect square. Square root is x. 25, that's a perfect square. Square root is 5. All right, I got this. Plus, minus, drop the mic, I'm done. No, you just got it wrong. And why did you get it wrong? Because they tricked you by changing that minus to a plus. The one thing we didn't say is, why is this called difference of squares? Difference is a fancy alternative way of saying subtraction. The difference of two things is when you subtract one from the other. So it has to be subtracted, because that's what difference of squares means. It's talking about these. These are the squares, and it is the difference of them. It has to be subtracted. It can't be added. The difference of squares things has nothing to do with that. That's not why it's called that. The name has to do 100% with the fact that it is a difference of two squares. It has to. I cannot say that and stress that enough. It has to be minus. I've just seen it too many times. It's going to come up. If you ever do see something like that, where you get the test and it says 16x squared plus 25 like that and asks you to factor it, you cannot factor it. This example right here. This example where it's just two ordinary squares, there's nothing to pull out, there's no greatest common factor, there's none of that stuff going on. It's just two squares and they want you to factor, and they're trying to trick you into using difference of squares. Nope, it is not factorable. Okay, I think that's everything on that topic. So if you enjoyed this video and would like to see more videos for all of your math-related needs, please visit my channel or one of my different playlists. Thank you so much for watching. Please be sure to like and subscribe. It helps a bunch. Hope you have a great day. Bye-bye.